So you remember last week we worked on solving quadratic equations, and we practiced solving quadratic equations by graphing. We also reviewed solving quadratic equations by taking square roots. And then last week we started seeing some equations where we saw a new type of number that we haven't worked with before, called an imaginary and complex number. So today we're going to look at some operations with complex numbers and how we can use them in Algebra 2. So today's notes will be operations with complex numbers. Make sure you put today's date in the top corner there. Let's just review again what complex numbers are. Complex numbers are in the form a plus bi. A is the real part of the numbers you're used to seeing, and the bi is the imaginary part, which is the new numbers that we're seeing. And then remember, the I stands for the square root of -1. So if I gave you some complex numbers, you should be able to break them up into the real and complex part. So for example, it said I gave you this complex number, 5 plus 2i. The real part of that number is 5, and the complex part is the 2i. So anything with the I term is complex. If I gave you -3 plus 4i, the real part is the -3, the complex part is 4i. If I just gave you the number 4i, there isn't a real part to this one, so we put 0, and the complex part is 4i. And on the other way of that, if I just gave you the number 2, the real number of this one is 2, and the complex part would be 0i, or which is just equal to 0, because 0 times anything is 0. And the last example, 2 minus I, my real part is 2, my complex part is -i. So imaginary numbers come up when you're solving quadratic equations and you get a square root of a negative number. And remember, we talked about rewriting square roots with that -1, turning it into an I. So this just allows you to continue working with problems when they have complex numbers and solutions that are different. So some operations we're going to work on with complex numbers are just adding and subtracting. So for adding complex numbers, it's similar to skills you've had before, where you combine like terms. A lot of times what you're going to see when you're adding complex numbers, here's an example. I'm going to take the complex number 5 plus 3i plus 4 plus 2i. When you're combining or adding complex numbers, you're just adding the real parts. So 5 and 4 are the real parts. And then the imaginary parts, you add those together as well. So I have 5 plus 4, which is 9. And 3i plus 2i is 5i. And that's it. So combining like terms, it's just like combining like terms. You look for the things that are constants, and you look for the imaginary terms, and you add those together. So as another example, let's say I gave you -1 plus 2i plus 2 plus I. I want to add the real parts of the complex number, so -1 plus 2. That gives me just 1. And then 2i plus 1i is 3i. Another example. Four minus 3i plus -2 minus 5i. So again, we're just adding the complex numbers. So I have 4 plus -2, that's +2. And I have -3i plus -5i, that's -8i. So when you're adding complex numbers, you just look for the like values in terms of the real numbers and in terms of the complex numbers and add those together. For subtracting complex numbers, subtracting complex numbers is very similar. Let's look at that original problem we did when we added. We'll do the same numbers again. 5 plus 3i minus 4 plus 2i. All right, so what you need to be careful of with these now is with the parentheses, the negative changes things. So what I like to do is I like to rewrite these problems without parentheses. So the first set of complex numbers here, this just stays the same. This stays as 5 plus 3i. But here, it's kind of like having an imaginary 1 there. So I'm distributing -1 to each thing inside of the parentheses. So this becomes -4 minus 2i. And now, just like we did with adding complex numbers, you just combine the real parts and the imaginary parts, and that's your final answer here. So this one gives me 1 plus I. So the only thing that's different with subtracting is that this negative will change some of the things that are happening, because you have to change the sign of the second two parts of the complex number. So let's try another example. Say I gave you -3 plus I minus 4 plus I. So again, I'm going to rewrite it without the parentheses. I'm going to distribute that -1. So it's -3 plus I minus 4 minus I, because I have to distribute -1 to each of these things. That's a common mistake people will make. So -3 minus 4 is -7. And then I take away I is 0, so I can just write down the -7. Try one more example. We have 10 minus 3i minus 5 minus 2i. I'm going to get rid of the parentheses again, so 10 minus 3i stays the same. And I'm going to distribute this -1, so it's -5 plus 2i. And now it's just combining like terms. So if you're adding, you just add the terms because the addition doesn't change the signs. But when you're subtracting, you have to be careful of these second terms here, because you're actually changing the sign of them and then combining like terms. So that's operations with complex numbers. You're just adding and subtracting like terms. So we're going to keep practicing that this week.